In this episode, we're going to take a concept that can feel like it belongs in a planning meeting and show how it can directly improve what defenders catch in the real world. Detection work often starts with a pile of alerts and a vague desire to be better at spotting bad behavior. But that approach can turn into endless tuning without a clear sense of what success looks like. Intelligence requirements, IRS, give you a way to define what you need to know about threats in order to make decisions, and that definition becomes a blueprint for what your detection should look for. When you connect detection engineering to IRS, you stop building detections because something seems scary and start building detections because they answer questions your organization must be able to answer under pressure. This shift also prevents detection teams from drowning in noise, because IRS help you prioritize which behaviors matter most and which signals are worth the cost of collection and review. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. An IR is not a report topic, and it is not a trendy phrase you add to a slide, because it is a disciplined statement of information needs tied to a decision. A well-formed IR sounds like a question the organization must be able to answer, such as whether an adversary is attempting credential access in the environment or whether there are signs of lateral movement toward critical systems. The important part is that the question is specific enough to drive collection and detection, but broad enough to remain useful even when the adversary changes tools. Beginners sometimes assume intelligence is only about naming a threat actor, but IRS are often more practical, focusing on behaviors, objectives, and risk to key assets. When you treat IRS as decision-linked questions, you naturally begin to ask what evidence would let you answer them quickly and reliably. That evidence is where detection engineering comes in, because detections are one of the main ways organizations collect timely answers at scale. The connection between IRS and detections becomes clearer when you think of a detection as a mechanism for producing a recurring, testable answer. If an IR asks whether certain high-risk authentication patterns are happening, a detection should reliably surface those patterns when they occur and should provide enough context for a defender to judge whether the event is benign or malicious. If an IR asks whether persistence is being established on endpoints, a detection should look for behaviors that indicate new persistence mechanisms and should link those behaviors to the system, user context, and timing that matter. This is different from building detections based on one-off indicators, because indicators can burn quickly while the underlying question remains. When the question remains stable, detections built around it remain valuable, and tuning becomes easier because you know what the detection is trying to prove. The detection is no longer an alarm. It is evidence generation aligned to an intelligence need. A practical way to start is to translate an IR into the observable behaviors that would answer it, because this translation step is where beginners often get stuck. If the IR is about credential access, the observable behaviors might include unusual login patterns, unusual token usage, unexpected privilege changes, or authentication attempts from atypical sources. If the IR is about lateral movement, observable behaviors might include remote execution patterns, new administrative sessions between systems that rarely interact, or sudden access to internal services that indicate expansion. If the IR is about data collection and staging, observable behaviors might include unusual access to sensitive repositories, compression activity in unexpected locations, or new outbound transfer patterns tied to that access. Notice that none of these require you to name a specific tool, because they describe effects and methods rather than brands and binaries. This behavior-first translation is how you keep IR-driven detections resilient, because adversaries can change packaging but cannot easily change the need to perform certain actions to achieve objectives. Once you have behaviors, the next step is mapping those behaviors to data sources, which is where detection work becomes real and where many detection efforts quietly fail. Detections can only work on signals you can collect, retain, and correlate, and this is why IRS should influence logging priorities rather than only alert rules. Authentication behaviors might require identity logs, system logs, and contextual asset data that explains what normal looks like for a user or service. Endpoint behaviors might require endpoint detection and response, EDR, telemetry, or equivalent host visibility that captures process creation, persistence changes, and suspicious parent-child relationships. Network behaviors might require flow records and domain resolution context, so outbound patterns can be seen at scale. Central correlation often occurs in a security information and event management (SIEM) platform, but the platform is not the point, because the point is whether the organization can observe the behaviors that answer the IR. If you cannot observe them, then the IR becomes a driver for improving collection, not a blame statement about defenders missing something. A common beginner misunderstanding is thinking that detection engineering is mostly about writing clever rules, when in reality good detections are built on careful scoping and context. An IR helps with scoping because it forces you to decide which assets, accounts, and workflows matter most to the decision behind the question. If the decision is about protecting core identity systems, then detections should focus on behaviors near those systems, not only on random endpoints across the environment. If the decision is about preventing data theft, then detections should emphasize access to sensitive stores and the pathways that lead to them, not only generic malware artifacts. Context also includes what is normal in the environment, because without a baseline you cannot reliably interpret anomalies. IR-driven detection work encourages teams to define normal relative to the decision, such as what normal admin activity looks like on critical servers versus on user workstations. This targeted baseline approach reduces noise because you stop treating every deviation as equal and start treating decision-relevant deviations as the priority. It also helps to use a shared behavior vocabulary so that intelligence teams and detection teams are describing the same things consistently. Many organizations use MIT, EATT, and CK as a common reference for tactics and techniques, not because the framework is magical, but because it offers a structured way to describe adversary behavior. If an IR is framed around a tactic like credential access or lateral movement, that framing can help detection engineers choose which techniques and procedures are most relevant to monitor. The key is to avoid turning the mapping exercise into a checkbox activity, where you try to cover everything because the framework is large. Instead, you use the framework to clarify what behaviors matter most for your environment and your decision needs. When intelligence reports that an adversary pattern often relies on certain techniques, that guidance should directly inform detection priorities, such as which behaviors deserve stronger coverage, faster alerting, or richer context enrichment. In this way, the IR acts like a funnel that narrows vast behavior libraries into a practical detection backlog. Another important concept is that IR-driven detection engineering should define what success looks like in measurable terms, because otherwise detection work becomes endless tuning without closure. Success is not simply that the rule fires, because a noisy detection that fires constantly is not a success for defenders. Success is that the detection produces a manageable volume of high-value alerts, provides sufficient context for triage, and contributes to answering the IR quickly. For example, if the IR is about identifying credential abuse early, success might include detecting suspicious authentication within a short window and correlating it with subsequent privilege changes or access attempts. If the IR is about catching persistence establishment, success might include detecting persistence creation with enough detail to support containment and scoping, rather than a vague signal that something changed. These outcomes help teams tune in the right direction, because you can evaluate whether changes improve decision speed and accuracy rather than merely reducing or increasing alert counts. IRS make detection evaluation decision-centric instead of vanity metric-centric. IRS also help detection engineering handle the trade-off between precision and recall in a more disciplined way, even if you never use those math words out loud. Some IRS demand early warning, meaning you prefer to catch more potential signals even if some are false positives, because the cost of missing a true event is high. Other IRS demand high confidence, meaning you prefer fewer alerts with stronger evidence because the response actions are disruptive or expensive. For instance, an IR tied to protecting critical identity infrastructure might justify broader early warning detections that trigger investigation, while an IR tied to automatically isolating systems might require higher confidence thresholds to avoid harming operations. When detection engineering is guided by IRS, you can justify these design choices in plain language, tying them to the decision consequence rather than to personal preference. This reduces internal conflict because teams stop arguing about whether a detection is too noisy in the abstract and start discussing whether it is fit for the decision it supports. Fit for purpose becomes the guiding principle. Another way IRS strengthened detection engineering is by shaping enrichment and correlation, which are often the difference between an alert that wastes time and an alert that saves time. A raw event might be technically suspicious, but without asset criticality, user role context, and prior related activity, a defender may not know how urgent it is. If an IR is about protecting a certain data set or a certain business function, then detections should enrich alerts with whether the affected system is in scope for that function and whether the user involved has expected access. If an IR is about lateral movement, detections should correlate authentication, remote execution signals, and network connections to show whether the event is part of a sequence rather than an isolated anomaly. Correlation is not about making the alert look impressive. It is about making the alert answer more of the IR immediately so defenders do less manual digging. When you engineer detections with the IR in mind, enrichment becomes intentional because you know what context is needed to support the decision behind the question. IR-driven detection engineering also creates a healthier relationship between intelligence and defenders by building explicit feedback loops. If a detection was built to answer an IR and defenders consistently close its alerts as benign, that feedback is not a failure, because it is information about either the environment's normal patterns or the detection's assumptions. The team can ask whether the IR is still valid, whether the behavior definition needs refinement, or whether additional context is needed to separate benign from malicious. Conversely, if a detection repeatedly surfaces true malicious behavior, that outcome strengthens the underlying IR and may justify expanding coverage or reducing response time. Over time, this loop helps intelligence teams update their understanding of adversary procedures in the environment, while detection engineers update their rules to reflect what actually works. The organization learns faster because the IR creates a shared reference for what the detection is for and what the defender should be getting out of it. Without that shared reference, feedback often becomes vague complaints about noise rather than actionable improvement. It is also important to recognize that IRS can prevent a common strategic mistake, which is building detections that are technically clever but operationally irrelevant. A detection might catch a rare artifact that almost never appears, producing a satisfying sense of coverage, while missing the behaviors that drive the highest risk. IRS force you to confront relevance by tying detection work to decision outcomes, such as protecting critical assets, reducing dwell time, or catching lateral movement early. This prioritization matters because every detection has a cost in engineering time, data collection, storage, and human review. When you create a detection backlog from IRS, you are implicitly budgeting resources toward the questions that matter most, and you can explain that budget to leaders in plain terms. Instead of saying we built 40 new rules, you can say we improved our ability to answer whether attackers are attempting credential access and whether they are moving toward critical systems. That is a far more meaningful statement, and it reflects why intelligence and detection should be linked. Another subtle benefit is that IRS help you design detections that remain effective through adversary change, because adversaries adapt and static indicator coverage decays. If detections are built around answering behavior questions, they will continue to surface suspicious activity even when the adversary swaps payloads, changes domains, or shifts tooling. This does not mean adversaries cannot evade, because they can, but it does mean your defensive posture is less brittle. It also means your detection program becomes easier to evolve, because when new intelligence arrives, you can ask whether it changes the priority of certain IRS or adds new behavior expectations under existing IRS. The detection program becomes a living system aligned to evolving intelligence, not a pile of rules that slowly rots. When defenders see that detections remain useful across changes, trust grows, and trust improves adoption, because defenders are more likely to act on alerts that have proven aligned to real threat behavior. In this sense, IRS improve not only engineering discipline, but also operational confidence. As we wrap up, Driving detection engineering with IRS is about turning intelligence from interesting context into a disciplined engine for building detections that answer decision-linked questions. You start by expressing IRS as clear information needs tied to outcomes, then translate those needs into observable behaviors that are resilient across tool changes. You map those behaviors to data sources and visibility, using gaps as a prompt to improve collection rather than pretending the data exists. You scope and enrich detections based on what matters to the decision, using correlation to turn raw events into actionable evidence for defenders. You define success in terms of decision speed and accuracy, calibrate alerting to the consequence of the decisions, and build feedback loops so detection and intelligence refine each other over time. When you do this consistently, detections stop being random alarms and become a structured way of knowing what is happening in your environment, which is exactly what intelligence is supposed to support. The result is a defense program that learns faster, focuses better, and catches meaningful adversary behavior earlier, even as the threat landscape shifts.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.